Hello my dear friends, welcome back to your channel of learning mathematics. We have already done an introduction on chapter 6 where I've talked about the concept of similarity, its difference with congruency. So kindly go through it. So today we're going to start off with the first topic that is included in chapter 6 of class 10, triangles, basic proportionality theorem or Thales theorem. So as you all know, these theorems are very important in geometry, just like algebraic identities. It's very important for us to solve the exercise questions. Now, before we really jump into this basic proportionality theorem, we will need 2 or 3 concepts today. The first one is a very simple concept, that is, everybody knows what is the area of a triangle formula, isn't it? If you have an altitude given to you or a perpendicular height given to you. So if AD is the perpendicular height, then BC becomes the base. So area of triangle can be written as half of base into height, that is half of base BC into height AD. If you wish, you can write down the base as BD also, really doesn't matter. The second concept that we will also again require is if you have 2 triangles on the same base and between same parallel lines. If you have 2 triangles on the same base and between 2 parallel lines, I mean these 2 lines are parallel. So maybe one triangle we have something like this. Okay. And the other triangle something like this. So we can see that these 2 triangles are between the same parallel lines and on the same base. Then in class 9 we have learned one theorem that the areas will be the area of the 2 triangles which lie between the same base and between parallel lines will be equal. Or in other words, I can draw the figure also like which we'll be requiring here. Suppose you have 2 parallel lines like this, and maybe this is one triangle. Have a look properly. This is one triangle and the other triangle is maybe something like this. Then also we can see that they share the same base, isn't it? These 2 triangles, they will be sharing the same base and they are also between the same parallel lines. So area of this triangle will also be equal to area of this particular triangle. Why? Because they are lying on the same base and between the same parallel lines. Alright, similar to this only. Here we can consider the same base to be this. Either way, okay, either way it's all the same. It depends on which triangle are you talking about. Alright, so these 2 concepts we will require here today. So let's go and have a look at the theorem. It says that if a line is drawn parallel to one side of a triangle. So for that, let us consider a triangle. Let's consider any triangle. Let's say this. So if we consider one triangle, let's name this as, let's say, A, B and C. If a line is drawn parallel to one side of a triangle, any one side, to this side, to this side, to this side. So I'll just draw with respect to the textbook. Maybe this is one line that I have drawn parallel. Okay, let this line be, let's say, L. So these 2 lines are actually parallel. To intersect the other 2 sides, so this line definitely intersects the other 2 sides, isn't it? This line is parallel to this side, third side, and it intersects the other 2 sides at distinct points. Distinct point means different points. So let's say it intersects at D and it intersects AC at E, AB at D. Then the other 2 sides, these 2 sides, now AB and AC, are divided in the same ratio. Same ratio means these 2 sides will be divided in the same ratio by this line at the point, that is AD by DB. Its ratio will be same as AE by EC, or any way you wish to take. You can also take AD by AB is equal to AE by AC. It has to be corresponding though. Alright, okay, clear? So for that construction, what we will draw is, we will draw perpendiculars, let's say DG, okay, on AE, and another perpendicular, let's say EF. Okay, so these are perpendiculars on AD. I'll just join BE also, and I'll join CD also. Okay, so that completes my triangle. So what is given to us? It says a triangle ABC and line, let's say L, parallel to NBSE intersects AB and AC at D and E respectively. That means respectively means AB at D and AC at E. To prove, just one of the proofs we can to prove that this line divides the two sides in the same ratio. That is, we can prove AD by DB is equal to AE by EC. That would be enough. So for that construction, what we will do is we join BE and CD. We also draw DG perpendicular to AE and EF perpendicular to AD. Proof. So I'll write down the proof. Like, we know that this is just the base. Okay, we know that area of triangle is equal to half into base into corresponding altitude. Corresponding means whichever altitude we are deciding. So now what we will do is I will consider the altitude AE. Okay, so see, now this AE is an altitude, can be considered as an altitude for two triangles. What will they be? ADE and BDE. All right, so to clear that for you, I mean DG also can be considered, yeah, it's up to you, whichever triangle you wish to take like first. Okay, so I'll take ADE and DBE. So for that, EF is the perpendicular altitude. So just to clarify the figure, I've drawn like this. So I've just removed the other sides which are not needed. Okay, so that's ADE. So and DBE. We can see that this is the altitude for both of these triangles. So if you're slightly confused, have a look at this triangle in this way. Let's say something like this. Of course it doesn't look okay. Let's say something like this. Okay, so if you look at the triangle like this, you will see that EF is the altitude for triangle ADE. So in triangle ADE, area of triangle ADE can be written as half into base, this time I can consider as AD, into height, I'm considering it as EF. In triangle, now if we consider triangle DBE, this triangle. So this triangle, if we extend this side, then we have the height, isn't it? So in that case, the base becomes BD. Or the base can also be written as BF, but that's not within our point. I mean, we just want this BD, so we'll just go for this BD. Otherwise, it's extended side of BD only, so it doesn't matter really. Okay. So in triangle DBE, area of triangle DBE would be half into, what is the height that we're considering? EF. EF is the height. So this is the side on which the height is standing. So we are going to just extend the side BD. So BD becomes the base. All right. So let me mark this as equation 1 and equation 2. So what I'll do now is I will divide equation 1 and 2. So in that case, it becomes area of triangle ADE upon area of triangle DBE. So that would be half into AD into EF divided by half into BD into EF. Okay. So with that half cancel, EF we can cancel, isn't it? So we will be left with AD by BD. We can mark this as equation number 3. Okay, so this side done for the height altitude EF. Let's move to that side, that is DG. So that will be again ADE, and this time it's going to be DG. So we're going to consider this side of the triangle, that is DCE. So again, let's say in triangle ADE, so I've again drawn the triangle ADE for you, this side of the triangle. Okay, it's actually like this ADE DC. So I'll just convert that so that it's going to be not confusing for us, sorry. So in that case, area of triangle ADE would be half into height would be DG. Then if height is the DG, then base for this triangle will be AE. All right. And in triangle, let's go for now DCE. DCE, area of triangle DCE would be half into height is DG. So base of course would be CE, or the extended side of CE, that is CG. So we are just going to need CE. So maybe I'll just mark, no problem. I'll just 1, 2, 3. So this one I'll mark as equation 4 and this one I'll mark as equation 5. So again, dividing equation 4 by 5. So that will be area of triangle ADE divided by area of triangle DCE. That would be half of AE into DG divided by half of CE into DG. So here also DG cancel, half cancel. So what are we left with? AE by CE, equation 6. All right. Now if we have a look at the figure once again, what did I tell you in the beginning? That if we have two triangles which are lying on the same base, have a look closely, and between the same parallel lines, then the areas of those two triangles will be considered as equal. Then the area of those two triangles will be considered as equal. Now have a look closely. You see, after I've shaded, I think it's more clear now, isn't it? So we can just write, no problem, since triangle DBE and triangle CDE, I hope that's clear, triangle DBE and CDE. CDE or DCE, let me just write, what did I write? DBE, and I'll just use DCE. Okay, I'll just write so that there are no confusions. Are triangles on the same base DE and between the same parallel DE and BC. So what will happen? Area of triangle DBE would be equal to area of triangle DCE. All right, clear? So this was our equation 6. Now let's rewrite that equation 6 once again. So equation 6, what was it? Area of triangle ADE divided by area of triangle DCE was AE by CE. So this can be written as area of triangle ADE divided by area of triangle, DBE. Why not? Because just now only we have proved, since area of triangle DBE is equal to area of triangle DCE. So instead of DCE, I can write as area of triangle DBE. So let's mark this as equation number 7. Now if you look at equation 3 and 7, what do we get? See, equation 3 is this. Equation 3, see, look at this. Area of triangle ADE divided by area of triangle DBE. Now, this was equation 3. So if you compare equation 3 and this equation 7, what do you see? This side is same, na? Area of triangle ADE, DBE, DBE. So what can we have? We can also have that AD by BD is equal to AE by CE. Or if you want to write it more properly, that would be AD by DB equal to AE by EC. Doesn't matter, but yeah, it's something like this. continuation AD by DB is equal to AE by EC. That way it will be much better, so you can just change that if you find any confusion. Okay, is that clear, my dear students? I hope that's fine for all of you. All right, so this can also be we can have other results also, like we can also have AB. Okay, if you look at the figure, we can also have AB by AD. AB by AD is equal to AC by AE. That is AB by AD equal to AC by AE. That can also happen. Or we can also have AB by DB. That is AB by this time DB equal to AC, corresponding sides, by EC. You can use any one of these results, even this also. That's up to you. That is what this theorem proves. Alright, so I hope you will be able to do this. This theorem will be important for you in the exams also. Alright, okay then, till then, take care. I'll see you in the next video. Bye bye.